Hello, Calc. It's Monday, the 6th of March. So welcome to Calc class. We are the topic today is MVTI. So let's recall, does that look familiar? The mean value theorem? I'm not going to take time to review what that is, but if you've forgotten totally, take a peeky-poo back into your comp book and bring that back to your memory. Tonight we're going to do the mean value theorem for integrals. Alright, the mean value theorem for integrals is stated thusly. Alright, if we have a function continuous on the closed interval a, b, then at some point c in that interval, this is true. The integral, the definite integral from a to b of f of x dx is f of c times b minus a. So this is just a number, and it equals the function evaluated at some point c times b minus a. Alright, it takes a picture to understand that very clearly. So I gave myself a function, and I gave myself an interval a to b. So we have learned that the integral, when it's positive, is going to be all this striped area from the function down to the x-axis. Alright, so I'm kind of trying to shade that. Alright, so that's whatever this area is, it's a number. It's going to be represented here by this expression on the left. But it can equal some c, say the c is right here, some value c in between, such that the function evaluated at c, so that's the height of this line, we can read it over here, here's f of c, so it's going to be this distance times b minus a. So do you see that if I have this height times this height, f of c, times this distance, I've got a rectangle. And the area of that rectangle will equal the area of the shaded part. So the striped rectangle, the area of that will equal the area that I shaded originally between the function and the x-axis between a and b. So this is an existence theorem. It says that there is a point C where this happens somewhere. So let's talk about that a little further. So I'm going to write that out in words so you can as well. So it's saying the area under the curve between A and B equals the value of the function at C times the length of the interval. And it's easier to see as a picture, but I'd like you to write it in words as well. Alright, so you can pause and get that down, and I'm going to go on. So now let's rearrange. So I'm going to rearrange this expression, got dark, this expression right here. I'm going to rearrange, and I'm going to get this by itself. So, doing that, I'm going to divide both sides by b minus a. Notice that rearrangement looks like this. When I divide it by b minus a, I brought it out in front of the integral, because the integral is in relation to x. So this is just a constant. It can come across the integral sign. And I put it here, 1 over b minus a times the integral from a to b of f of x dx equals f of c. This is called, and this has another name, and it's called the average value. this value right here, f of c, back to the picture, f of c, all these values exist. There are an infinite number of values between a and b, and they're read over here on this axis. So this value is read over here, this value is read over here. Once you find c, f of c is the average value. So we can also use this idea, rearranged like this, to find the average value. So they might not say in a problem, use the mean value theorem for integrals. They may use find the average value, but you know these are linked. So you'll think back to this lesson. All right, so let's do one. Find the average value at f of x, of f of x equals x squared from x equals 2 to x equals 4. So just what's going on in my thoughts. I'm going to have y equals x squared, the smiler. And I'm going to look at it between 2 and 4. And all the average of all the values is going to be somewhere in here. Alright, so let's just try to use the formula. So this is the formula for average value. Alright, so let's find it. So I'm going to put the 1 over b minus a becomes 1 over 4 minus 2 from the integral from 2 to 4 of x squared dx. And that will give me the average value. So you can see I plug those in. I'm going to take the integral, which will become x cubed over 3. First evaluate it at 4, and then subtract the value at 2. And then I'll apply whatever that answer is. I'll do all this first. I'll multiply it by 1/2, and I'll have the average value of that function. So there is my work as I stated. Now I put in the numbers, subtract it, multiplied by 1/2, and I got 56 over 6, which reduced to 28/3. Find the average value of this function on that interval, and the answer is 28/3. 28/3. So we will be practicing that. 28/3 is the value, the average value from here to here. We have all kinds of values between 2 and 4. They're all read over here, but 28/3 is the average. All right, so we'll stop there for tonight, and we will be exercising those problems soon enough. So till then, good night.